The bilateral nature of gravity and inertia. For centuries, physics has described attraction through two almost identical laws: Newton's law of gravitation and Coulomb's law of electrostatics. F equals g, frac m1 dot m2 r squared, q quad textan quad F equals k, frac q1 dot q2 r squared. Both express an effect between two entities that decreases with distance squared. Classically, the 1r squared 2 term is explained as the spreading of influence over a growing spherical surface. The farther apart two bodies are, the weaker the effect. That picture works, but it hides a deeper symmetry. The distance from body 1 to body 2 is exactly the same as from body 2 to body 1. So the r squared term does not describe spreading, but reciprocity. One distance acting in two directions at once. The hidden asymmetry in F equals ma. In Newton's formula, the force F represents the total interaction between both bodies. Yet in F equals mia, we apply that same total force to each body separately, as if each side experiences the whole effect. That silently doubles the acceleration whenever the masses are equal. In reality, the total acceleration must be bilaterally shared in proportion to the two masses. A1 equals A text total, frac m2, m1 plus m2. Quad A2 equals A text total for m1, m1 plus m2. When the two masses are identical, m1 equals m2, each receives exactly half of the total acceleration. Together, their combined effect still equals the total force F, but the symmetry of motion is now explicit. Neither object experiences the full force alone, they share it. The apple and the earth. When an apple falls, both the apple and the earth accelerate toward each other. The apple's motion dominates only because the earth's mass is so much greater. Its upward movement is about 10 squared 24 times smaller, but it exists. But it exists. We simply don't see it because our measuring instruments are on the earth. We move with the heavier partner in the interaction. From within the system, it looks as if only the apple moves. But an observer watching from outside the Earth-Apple system would clearly see both bodies move toward each other. The apple quickly, the Earth imperceptibly slowly. That is the real symmetric picture of gravity, a shared acceleration between two masses, two apples in space. Now imagine two apples, each weighing 1 kilogram, floating 1 meter apart in empty space. According to Newton, the total force between them is F equals G frac 1 text K drain 1 2 equals G. But that F is the combined effect of both apples. Each apple therefore experiences only half of that total acceleration, so that their motions together still produce exactly F as the total system effect. This is the true bilateral interpretation, the same total interaction divided evenly across both sides. In the classical view, we mistakenly give each apple the full F, which doubles the predicted acceleration of the system. The bilateral view restores the symmetry. Each apple accelerates halfway, and together their motions constitute the full gravitational effect. The ISS example, inertia revealed the end. The same symmetry appears aboard the International Space Station. If you throw a wrench forward, you drift backward. Nothing pushes you. It's the same bilateral acceleration at work. On Earth, your recoil is absorbed by the planet. In orbit, the mass ratio is only between you and the wrench, so your share of the acceleration becomes visible. We call that effect inertia, but it's really just gravity seen from the opposite direction, the same mutual relation with the acceleration vector reversed. Inertia and gravity, two sides of one relation. Gravity describes two bodies accelerating toward one another. Inertia describes the same acceleration when they move away from each other. Same magnitude, same symmetry, only the sign changes. That's why gravitational and inertial mass are not mysteriously equal. They are identical by definition. Both emerge from the same bilateral interaction. Gravity pulls, inertia pushes. Together they form one universal principle, the converging and diverging halves of motion itself. The consequence. Once we recognize that every acceleration is bilateral, force becomes not a cause but a balance, the visible remainder of a shared motion. From the falling apple to the drifting astronaut, from two apples in space to entire galaxies, the universe reveals the same truth. Open quote. All motion is mutual. Gravity and inertia are not opposites. They are reflections of the same shared acceleration. Close quote.